what is the solution to 3x plus 2 is equal to 15? Okay, here we're going to use something called a distributive property. This says that whenever we have a bracket, right, and a coefficient to this binomial, essentially, is we're going to distribute 3 to everything inside the bracket. So we're going to multiply by everything inside. So first we're going to do 3 times x, and then 3 times 2. 3 times x is 3x. 3 times 2 is 6. Okay, now what? The goal is to still solve x. When we're saying what is the solution to this, we're saying what does x equal to? What can we plug in for x to make this statement true? Okay, well, again, remember that we're going to be doing PEMDAS, but in reverse. So we have multiplication and subtraction, and addition, sorry. We're going to do addition and subtraction first before we deal with the multiplication. So we subtract 6 on both sides because if it's being added, we're going to subtract it to get rid of it. Cancels out. 3x is equal to 9. Now we're going to do division. We're going to divide because 3 is being multiplied. So to get rid of it, we have to divide. X is equal to 3. Before moving on, let's see how we could double check our work. So we actually just want to plug this into our equation again. We would say 3 times 3 plus 2 is equal to 15. And this is from the original equation here. We just plugged in x is equal to 3 here. 3 times 5 is equal to 15. 15, because 3 times 5 is equal to 15, is equal to 15. So left-hand side equals right-hand side. So this is true, and this is correct. Solve for y in the equation 4x plus y is equal to 12. Okay, now they want to solve for y, but as you can see in their list, right, we're not going to get a numerical value as our answer. We're actually getting an equation. So this is the same idea or thought process as we did before for isolating for a particular variable. So isolating for y is our goal here. Remember that isolating means that we want y on one side of the equal sign and then all the other numbers here, okay? So we want to separate them basically. So we say, okay, 4x plus y is equal to 12. So through some steps, we're going to end up with y is equal to something. Okay, well, what are these steps? Well, if we want to get y on its own, we're saying y needs to kick out its guest, and its guest is 4x. Well, how do we get rid of 4x? We could subtract it out. What we do to one side, we do to the other. 4x minus 4x is 0, plus y is equal to 12 minus 4x. So then y is equal to negative 4x plus 12, or 12 minus 4x. Either order, these make no difference in what order you choose. I also realize that the solution is in this order, so that's A. Okay, what is the value of z if z over 3 minus 2 is equal to 4? So this looks like z over 3 minus 2 is equal to 4. Okay, again, the value of z means we're isolating for z. We're going to do some steps to get z on its own. And how do we do that? Well, we're going to do PEMDAS, but in reverse. We're going to recognize that we have z divided by 3, so we have division, and we also have subtraction. So what do we do first? Addition and subtraction. Okay, so how do we get rid of this 2? Z says, I want to kick out this guest and put it on outside of the equal sign. Okay, well, since it's being subtracted, we're going to do the opposite operation of subtraction, which is adding. And what we do to one side, we do to the other. Cancels out. Z over 3 is equal to 4 plus 2, 6. Okay, now what? Okay, Z now says, I'm being divided by 3, but I need to get rid of this guest. How do I do that? Well, since 3 is the dividing factor here, we're going to multiply by 3. And then what we end up seeing is that 3 divided by 3 cancels out, right? Because 3 over 3 is 1. And what we do to one side, we do to the other. So z is equal to 18. We can double check this as well. We're going to plug it in. 18 over 3 minus 2 is equal to 4. And what we did is we plugged in the value we found for z into our original equation to see if it's right. 18 divided by 3 is 6, minus 2 is equal to 4. 4 is equal to 4, which is true, obviously, so left-hand side equals right-hand side. So this is true.